In the previous video, we went over the Born-Haber cycle, how to calculate the missing enthalpy of formation, and also how to calculate the lattice energy. Now, let's proceed and look at how to calculate some other things using a Born-Haber cycle. So we've been given to construct a Born-Haber cycle and to determine the bond energy of chlorine for the reaction that is going to happen using the data that we've been given. So what we want to form is sodium chloride. And so this happens when sodium, which is a solid, reacts with chlorine molecule. Okay. And now this forms sodium chloride. Well, we can see that 1 mole of chlorine comes up together with 1 mole of sodium. But what we have here is 2 moles of chlorine and 1 mole of sodium. So this is not a balanced reaction. To balance it, you're supposed to put a half here. I've not put a 2 in front of this and a 2 here because we are interested in 1 mole of this. If I put a 2 here, that means I'm supposed to put also a 2 there, and what we are going to form is not 1 mole. Alright. So the energy required for this to happen when this reacts with this to form this compound is called the enthalpy of formation, or the heat of formation. After this happens, well, by the way, this doesn't happen direct, just going like this. It is a stepwise reaction. And so first, the sodium, which is in solid state, is going to atomize into sodium in gaseous state, and then you are going to have half chlorine there molecule. Now the energy required to convert something from solid to gas is called enthalpy of sublimation, which also referred to as enthalpy of atomization. So what we are atomizing is sodium from solid to gas. And so after this happens, the sodium now can lose an electron to become sodium plus, and then plus half chlorine gas. Where we've lost an electron, we can show it there. So the energy that is required for a gaseous ionic compound or a gaseous atom to lose an electron is called ionization energy. So at this point we have got ionization energy. Alright. Now after this happens, this compound is also going to atomize. So I've got half chlorine, chlorine. So that's the meaning of a chlorine atom. To atomize means we want to break this bond, because as long as this bond is there, this reaction is not going to happen. So when that bond breaks, we are going to form 2 chlorine atoms. Now I can see that this 2 and that 2 is going to cancel, so I'm just going to remain with chlorine. Alright. So what we are going to have is sodium plus in gaseous form plus chlorine, a gas, and then plus an electron. So what has happened is chlorine has atomized. So I've got the enthalpy of atomization, which we can also refer to as the bond energy. Okay. At times also referred to as the enthalpy of dissociation, because chlorine is dissociating into its ions. Now after this happens, then we are going to see that the sodium, okay, not the sodium really, but the chlorine is going to gain this electron which was lost by the sodium. And so what we are going to have is sodium plus, which is a gas, plus chlorine minus. So when something gains an electron, it becomes negatively charged. And the energy that is required to do that, or the energy which is lost, the reason as to why we are seeing I have not progressed the reaction going up, instead I've brought it down like this, is because this, for this to happen, for you to take in an electron, energy has to be lost. That is why the reaction is dropping instead of continually going up like that. Okay. So electron affinity is the energy that is lost when a gaseous atom takes in an electron. So at that point now, this can go now, ions can go and form sodium chloride. Now the energy required for gaseous ions to form an ionic compound is called lattice energy. Actually, that is energy lost, because when gaseous ions, when atoms are forming a compound, energy is always lowered, so some energy is lost. But if this reaction was proceeding in that direction, the energy required for this to be broken, when you want to break a compound into its respective ions, you need to supply it with energy. And so going in this direction, energy is positive because we are supplying. So this is lattice energy at this point. Well, we can go now and substitute the value so that we are able to calculate what we are missing. Now, as you can see, the reaction is proceeding. For this arrow starting from this direction, the arrows are going in this direction, in the clockwise direction, up to lattice energy. But enthalpy of formation, the arrow is going in that direction. And so the anti-clockwise direction should be equal to the clockwise direction. Well, this is the anti-clockwise, this is the clockwise. So those are supposed to be equal. And so the enthalpy of formation is supposed to be equal to the others if we sum them up. So what we are saying is enthalpy of formation should be equal to enthalpy of atomization plus ionization energy. And then plus, now as we can see, for chlorine to atomize, it is a half mole of chlorine that is atomizing into chlorine atom. So half mole of chlorine molecule. So I'm supposed to put a half there. Actually, I was supposed to even add a half there. So it's half mole of enthalpy of atomization of chlorine. Okay, because it's only half mole of this that is going into that. And then now we have also electron affinity. Another thing that we have is lattice energy, delta H lattice. So from there we go to there and then we add that one. Now we can go on and substitute in the values. The enthalpy of formation, the value is there, that is negative 410.5. That should be equal to the enthalpy of atomization. The first atomization is for sodium. So the atomization for sodium, the value is there 107.3. And then ionization energy is there 495.8. And then we have got half enthalpy of atomization. This atomization is for chlorine. That is also referred to as the bond energy, the energy that is required to break a bond. Okay. And the next thing that we have is electron affinity, and the value given for the electron affinity is negative 348.6. So this will simply be a negative 348.6. And then plus lattice energy. Now the lattice energy is also negative, so this will be negative 787. So at this point we can just sum those values. Negative 410.5 is equal to 107.5, actually is 0.3, and then plus 495.8, and then the next value is negative 348.6, and then we have got negative 787. So that is giving negative 532.5, and then plus half enthalpy of atomization. This is for chlorine. So if we take this value that side, it becomes positive 532.5 minus 410.5, and that should be equal to half enthalpy of atomization. Now 532.5 minus 410, that is 410.5. So that is 122 is equal to half enthalpy of atomization. So to remain with the enthalpy of atomization, we're going to multiply it by 2. So therefore the enthalpy of atomization for this reaction is 244 kilojoules. Well, it is not kilojoules per mole, it's only kilojoules. Why? Because we are multiplying by a half mole. That is why it's not per mole. Otherwise, the value for per mole is this one, 122 kilojoules per mole, but we are talking of half mole. Okay. Let's look at another question. Construct a Born-Haber cycle and determine the lattice energy of magnesium chloride from the following data. So we've been given such a reaction. Well, we know that the first thing that should happen is for you to form a compound. In this case, we're talking of magnesium chloride. So magnesium which is a solid, has to react with chlorine gas, and when this happens, what is going to be formed is now magnesium chloride, which is a solid. So the energy required for this to happen is called enthalpy of formation. Now you can see that magnesium chloride contains 1 mole of magnesium and 2 moles of chlorine, and so we don't need to balance it, just the way it is. Alright, now this doesn't just happen like that. First, this magnesium has to be converted, has to be atomized. It has to be converted into magnesium into the gaseous form for the reaction to happen. So what is happening there when something is being converted into gaseous form? The energy required is called the enthalpy of atomization or the enthalpy of sublimation, when you're converting something into a gaseous form from solid to gas. So there it is, enthalpy of sublimation. Well, after this happens, then the magnesium has to lose first the first electron and then the second electron. Now from the data that we've been given, we can see that 2 electrons have been lost, so we just go direct. Magnesium is going to lose 2 electrons to become magnesium 2 plus, and then you have got chlorine gas there, and then those 2 electrons, are going to show them there. So the energy involved at this stage is called ionization energy. Is actually first and second ionization energy, because we are losing 2 electrons. Energy required to lose the first electron is called first ionization energy. Second electron, second ionization energy. But for this one, they've just put them together. Well, after this happens, this compound, the chlorine, has to atomize. So we have got chlorine molecule like that. There's a bond like this. So this bond has to be broken down. That is what is called atomization. And so we're going to form 2 chlorine atoms. So we're going to show that. So we have magnesium 2 plus in gaseous form, and then plus, now we are going to have 2 chlorine atoms in gaseous form, and then 2 electrons. The energy for this to happen is called the enthalpy of atomization, or simply bond energy. Let me name it as bond energy, like that. It's the same thing. Or the enthalpy of dissociation. Now after this happens, these 2 electrons will be gained by this. Okay. So each chlorine gains 1 electron to become chlorine ion, but there are the 2 of them. And so the energy drops, because when an atom gains an electron, energy is lost. Okay, energy is lowered. We have got magnesium 2 plus in gaseous form, and then we are going to have 2 chlorine ions like that. Those will be in gaseous form, because each chlorine has gained 1 electron and there are 2 electrons at that point. So because it is 2 moles of chlorine which have taken up each an electron, we are going to multiply by 2. So the energy required for a gaseous atom to gain electrons, or the energy lost, not required really, but the energy lost when a gaseous atom gains an electron, is called electron affinity. Okay, that is it. And so now these gaseous atoms or gaseous ions can now go direct and form this compound which is here. And the energy that is required for this to happen is called lattice energy. Lattice energy is defined as the energy released when 1 mole of an ionic compound, okay, not released, but what is happening here is when 1 mole of this ionic compound breaks into its gaseous ions, so it is going to take in energy, and such energy it takes in is called lattice energy. And so lattice energy can be defined in 2 ways. The energy required when 1 mole of ionic compound dissociates into its gaseous ions, or the energy lost when gaseous ions join to form one more of an ionic compound. So coming in this direction, energy is going to be lost, and so it will be negative. In that direction, the energy is going to be positive, but it is the same value. And so having had this, we know the values, of course, and we want to calculate the lattice energy. So what is missing is this. That is what we have to calculate. Now, as we can see, enthalpy of formation is in this direction. There's supposed to be an F there. And then the other values we can see at this point, the arrow is going like this, continues to go like that, and then it goes like this. Even the lattice energy, we can see that the arrow is going in this direction. And so the enthalpy of formation should be equal to all these other values added together. So if we are interested in the positive value of lattice energy, that would have been like this. And so the enthalpy of formation would have added to the lattice energy, and then that should have been equal to these other values up to this point. It's just that when we take this portion, the answer is going to be positive. If we go down as I've drawn, the answer is going to be negative. Well, let's go on and find the values. So the enthalpy of formation is here. I don't even have enough space to write. So we're saying enthalpy of formation should be equal to the first thing here, that is enthalpy of sublimation, and then plus what is there is ionization energy, and then plus the next thing there is bond energy, or the enthalpy of atomization. Then the next thing that we have is electron affinity, that is 2 times electron affinity. And then we have got that is the lattice energy. We'll go on the enthalpy of formation. We've been given when magnesium reacts with chlorine to form magnesium chloride, the value involved there is enthalpy of formation, as we can see here. So that is going to be negative 652, and that should be equal to the enthalpy of sublimation, the one involved here when magnesium is to be converted into magnesium gas, magnesium solid to magnesium gas. Okay, so we have got magnesium solid into magnesium gas, so the energy involved there is 132. And then plus ionization energy, the energy required to remove an electron from a gaseous atom. Magnesium in gaseous form is losing these 2 electrons, so that is the ionization energy. The energy involved is 2170 kilojoules per mole. And then we have got the bond energy, the enthalpy, or the energy that is required to break a bond in chlorine. So we have got chlorine going into 2 chlorine atoms. Such is the bond energy required to break that bond, that is 236. And then we have got 2 times electron affinity. So this is electron affinity, the energy required for chlorine atom to be converted into chlorine ion, and that we can see it here. So the one we've been given is for 1 more, but we have got 2 moles, that is negative 342. And then we want the lattice energy, which we don't know, plus delta H lattice. So I can go on and sum this value, that is negative 652 is equal to, we have got 132 plus 2170, 2170, plus 236, and then plus 2 times negative 342. So that gives us a positive value of 1854, and then this should be plus this one, which is delta H lattice. Well, to remember that lattice energy, we're going to take this value the other side, so that is going to be negative 652 minus 1854. That should be equal to the lattice energy. Now if we add these 2 values, or we subtract them, 1854 plus 652, that is going to give us a lattice energy equal to negative 2506. This is in kilojoules per mole. So the unit is kilojoules per mole. Because we are forming 1 mole of compound. So that is the value then. That is the answer for this question.